Hello everyone, and welcome back to the video lecture series on rational expressions. Today we are going to be looking at solving equations that contain fractions, specifically fractions that contain variables in the denominator. So you have covered how to solve equations with fractions before, back when you solved linear equations where all of your coefficients were fractions. So what you can do is, if you have a lot of fractions, you can eliminate the fractions by multiplying every single term on both sides by the lowest common denominator of all of the fractions. This will eliminate the fractions, allowing you to solve as normal. So for example, let's take this equation and we're going to eliminate the fractions and we're going to solve it for x. So let's take a look at the three denominators. We have 2, 5, and 10. The goal is to eliminate the fractions by finding the lowest common denominator between all three of these. So the lowest common denominator between 2, 5, and 10 is going to be 10. So what I'm going to do is I'm going to multiply every single term on both sides by 10. So I'm going to take this 1/2 x, I'm going to multiply it by 10. I'm going to take this 1/5 x and I'm going to multiply it by 10. And I'm going to take this 7/10 and I'm going to multiply it by 10. And what I'm going to do is I'm going to do any simplifying that I can to eliminate the fractions. So looking over here, there's a 2 in the denominator and a 10 in the numerator. They have a common factor of 2, so 2 divided by 2 is 1, 10 divided by 2 is 5. Then same thing over here. This 5 and this 10 have a common factor of 5, so 5 divided by 5 is 1, 10 divided by 5 is 2. And then over here, 10 divided by itself is 1. And then after we simplify, we're going to multiply what's left over. So you have 1x times 5, which is 5x, plus 1x times 2 is 2x, equals 7 times 1 is 7. So what that did was that eliminated the fractions, and that is going to allow us to solve for x. So I'm going to combine these two like terms. 5x plus 2x is 7x, equals 7. Then divide both sides by 7, and we get x equals 1. So that is going to be the pretty much same idea when we solve rational equations. So you can clear out fractions by multiplying every single term on both sides by the lowest common denominator. And then the process for finding the lowest common denominator for fractions that contain variables in the denominator is going to be the same as the process that we've used in the last two videos. And then the key is we're going to reduce as we go, and that should eliminate the fractions. This will result in some sort of equation, either linear or quadratic, that you can solve. Now, another method that you can use to solve rational equations is cross-multiplying. So remember that a proportion occurs if two fractions are equal to each other. So you've solved, proportions like this before, where you just cross-multiply to solve for x. This means that when you have two fractions equal to each other, you can simply cross-multiply. So for something like this, when you have one fraction on the left side of the equal sign and one fraction on the right, you can cross-multiply. The key is you can only cross-multiply when there are two fractions, one on the left and one on the right. If there are more than two fractions, you cannot use the cross-multiplying method. You are going to have to use the lowest common denominator method. Now, here's one big difference between rational equations and regular linear equations. There are some equations that contain no solution. So that is what is called an extraneous solution. An extraneous solution occurs when you go about and you solve the problem and you get a number that looks like it should be an answer. It looks like it should work. But when you plug it back into the original equation, it doesn't actually satisfy the equation. A number that looks like it should be a solution but doesn't actually work is called an extraneous solution. So you could do your algebra perfectly and still run into an extraneous solution. These happen all the time. So you must always look for them, because they do kind of come up without warning, and even if your math is perfect, you can still get these. So for every single one of these problems, you must check your solutions every single time. So I don't care how confident you are in your math. I don't care how good you think that you're doing with the algebra. You have to check your answers because you can get a solution that looks like it should work but doesn't actually work. So because extraneous solutions are going to be a reality in this section, every single answer must be checked. So this is an example of a rational equation. It's slightly more complicated, where it contains a whole lot of fractions. So what I'm going to do first is I'm going to put parentheses around the x minus 8 and the x minus 3, and I'm going to find the lowest common denominator. So the lowest common denominator between 3, 2, and 1 is 6. So to make this a little bit easier, I'm going to multiply every single term on both sides of the equation by 6. Keep in mind, please put parentheses around both of those numerators. So I'm going to have x minus 8 over 3, and I'm going to multiply it by 6. Then I'm going to have x minus 3 over 2, and I'm going to multiply it by 6. Don't forget, whatever you do to one side of an equation, you have to do to the other. So I'm going to take 0, and I'm going to multiply it by 6. And then I'm going to reduce as I go. So 3 and 6 here have a common factor of 3. So 3 divided by 3 is 1. 6 divided by 3 is 2, giving us 2 times x minus 8. Then over here, 2 and 6 have a common factor. So 2 divided by 2 is 1. 6 divided by 2 is 3, giving us 3 times x minus 3. And then on the right, 0 times 6 is 0. So it doesn't look like it did much, but it eliminated the fractions, and this is now a linear equation that we can solve like we normally would. So I'm going to clear out both parentheses using distribution. So 2 times x is going to give us 2x. Then 2 times negative 8 is minus 16. Then 3 times x is plus 3x. And then 3 times negative 3 is negative 9 equals 0. I'm going to combine the terms that have an x, so 2x plus 3x is going to give us 5x. And I'm also going to put together this minus 16 minus 9, which is negative 25. Then I'm going to add 25 to both sides to give us 5x equals 25. And then I'm going to divide both sides by 5, giving us x equals 5. Now notice I did not circle my answer yet because for every single one of these, you need to go back and you need to check your answers. So we're just going to check our solution by plugging 5 back into the original equation into every single spot that we see an x. So I'm going to plug a 5 in right here and right here. So I will get 5 minus 8 over 3 plus 5 minus 3 over 2, and we're going to see if that equals 0. So 5 minus 8 is negative 3 over 3, plus 5 minus 3 is 2 over 2, and then negative 3 divided by 3 is negative 1, plus 2 divided by 2 is 1. Negative 1 plus 1 does indeed equal 0. So because we essentially got the same number on both sides of the equal sign when we checked our solution, that means x equals 5 is actually our solution, so we get to circle it and call it done. This next one is going to be a bit more complicated since the denominators contain variables. I am going to put parentheses around the x plus 7 right away. Now, because there is only one fraction on the left and one fraction on the right, you can use cross multiplying to solve this. So when you cross multiply, just keep in mind that you need to keep the x plus 7 together with parentheses. And you're going to set their cross products equal to each other. So I'm going to take this x plus 7 times 8 and write it as 8 times parentheses x plus 7. Yes, you will need to distribute. Then I'm going to set that equal to 6 times x is 6x. Then this eliminated the fractions, and this generated a linear equation that we can solve. So I'm going to distribute the 8, giving us 8x plus 56 equals 6x. Then I'm going to move all of the x terms on to one side. So I'm going to just subtract 8x from both sides, giving us 56 equals 6x minus 8x is negative 2. Then I'm going to divide both sides by, negative 2x. Then I'm going to divide both sides by negative 2. And that is going to give me x equals negative 28. Now, don't forget, before you circle it and call it your answer, you do need to check it. Every single time, you do need to check your answers. So to check your answer, you're going to take negative 28 and you're going to plug it back into the original equation into every single spot that you see an x. So I have 6 over negative 28 plus 7 equals 8 over negative 28. So negative 28 plus 7 is going to give us negative 21. We're going to see if that equals 8 over negative 28. Now for something like this, remember, you can absolutely use a calculator. You are allowed a calculator in this class. So if you do 6 divided by negative 21, you get negative 0.2857, blah, blah, blah. Then if you do 8 divided by negative 28, you get the exact same decimal. So because we got the same number on both sides of the equal sign, that means x equals negative 28 is our solution, so we get to circle it and call it our solution. Now for this next one, remember you can always turn a whole number into a fraction by putting it over 1. As soon as you turn this 5 into a fraction, suddenly you have one fraction on the left and one fraction on the right. Because you have exactly two fractions, one on the left and one on the right, you can cross multiply to solve this. When you cross multiply, just remember that you do need to put parentheses around the 2x minus 2 because that entire denominator is going to get multiplied. So let's do some cross multiplying. So I got 2x minus 2 times 5 is going to give us 5 times parentheses 2x minus 2. Then I'm going to set that equal to the other cross product. 10 times 1 is 10. So I now have a linear equation that I can solve like normal. All of the fractions are gone. So I'm going to distribute this 5. So 5 times 2x is going to give us 10x. And then 5 times negative 2 is going to be minus 10 equals 10. And I'm going to solve for x by first adding 10 to both sides. Gives me 10x equals 20. Then I'm going to divide both sides by 10, giving us x equals 2. Which I am not circling yet because remember, every single one of these, you need to check your solutions. So to check my solution, I'm going to plug 2 back into the original equation in for where I see an x. So I have 10 over 2 times 2 minus 2. We're going to see if that equals 5. So 2 times 2 is 4. 4 minus 2 is 2. 10 divided by 2 does indeed equal 5. So because we got the same number on both sides of the equal sign, that means x equals 2 is our final answer, and we get to circle it. So this next one is basically going to be a very similar idea. Remember, if you want to try this next one on your own before I go over it, just feel free to pause the video and then press play whenever you are finished. But I'm going to turn this whole number 4 into a fraction by putting it over 1. And I'm going to put parentheses around the 5 minus 3x because that does need to be kept together. Now because I have two fractions, one fraction on the left side of the equal sign and one fraction on the right, I can cross multiply. Just keep in mind when you cross multiply, you do need to put parentheses around that 5 minus 3x. So let's cross multiply. We have 5 minus 3x times 4 is 4 times parentheses 5 minus 3x. Then we're going to set that equal to 12 times 1 is 12. Then this eliminated all the fractions and gave us a linear equation that we can solve. So I'm going to distribute the 4 to clear out the parentheses, giving us 20. And then minus 12x equals 12. Then I'm going to begin getting x by itself by subtracting 20 from both sides. So I get negative 12x equals 12 minus 20 is negative 8. Then I'm going to divide both sides by negative 12. And I get x equals 2/3. Remember, you can get a fraction as a solution. Just remember that before you circle that solution, you do need to check it. So I'm going to check my answer by plugging 2/3 back into the original equation in for x. So I have 12 over 5 minus 3 times 2/3. We're going to see if that equals 4. So 3 times 2/3 is 2, because the 3 and the 3 are going to cancel out. Then 5 minus 2 is 3. 12 divided by 3 does indeed equal 4. So because we got the same number on both sides of the equal sign, that means x equals 2/3 is our final answer. Now for this next one, at first glance, it doesn't look like you can cross multiply because there are 3 fractions. However, we've got this 1 here on the left side of the equal sign and this 3 over here on the right. So what I'm going to just do really quick is I'm going to just subtract 1 from both sides first and then combine some like terms. So that will give us 2 over x equals 3 minus 1 is 2. Now that we've combined some like terms, now we have 1 fraction here on the left and 1 fraction here on the right. Because we have exactly 2 fractions, 1 on the left and 1 on the right, we can cross multiply. And this one's going to be really easy. You could probably figure out what the answer is just by looking at it. But if we cross multiply, we get x times 2, which equals 2x, equals 2 times 1, which is 2. Then divide both sides by 2, and we get x equals 1. So just don't forget that before you call it good, you do need to check your solution by plugging 1 back into the original equation. So 1 plus 2 over 1, we're going to see if that equals 3. 1 plus 2 does indeed equal 3. So x equals 1 is our final answer. So if you run into something like this, remember you can combine whole numbers because they are like terms. So just move all of the whole numbers onto one side of the equal sign, and then you should be able to cross multiply. This next one's going to be pretty much the same idea. We've got a whole number 1 here on the left and the whole number 2 here on the right. So I'm going to combine like terms. I'm going to first subtract 1 from both sides. Another thing that I'm going to do is I'm going to put that negative that is next to that fraction with the numerator. So I'm going to write that as negative 3 over x. That'll help make the cross multiplying a little bit easier. And then over here on the right, 2 minus 1 is 1. So I'm just going to turn 1 into a fraction really quick by putting it over 1. And then I have 1 fraction on the left and 1 fraction on the right. Because I have exactly 2 fractions, I can cross multiply. So let's cross multiply. We have x times 1, which is x, equals negative 3 times 1, which is negative 3. Nothing to solve here. Looks like x equals negative 3 is a potential solution. Remember, before you actually call it your solution, you do need to check it. So I'm going to plug negative 3 back into the original equation in for x. So I have 1 minus 3 divided by negative 3. We're going to see if that equals 2. So negative 3 divided by 3 is positive 1. 1 plus 1 does indeed equal 2. So because we got the same number on both sides of the equal sign, that means x equals negative 3 is our final answer. Now for this next one, cross multiplying is not an option because we have 3 fractions here, and it's not a matter of just simply combining some whole numbers. Cross multiplying is not an option. So because we can't cross multiply, we do have to look at the denominators of all 3 of these fractions. And we're going to find the lowest common denominator between all 3 of them. So the lowest common denominator between x minus 4, 1, and x minus 4 is x minus 4. So what I'm going to do is I'm going to multiply every single term on both sides by x minus 4, and I'm going to simplify as I go. So over here I have 3x over x minus 4. I'm going to multiply this term by parentheses x minus 4. Then I've got this plus 3 times x minus 4. And remember, whatever you do to one side, you need to do the exact same thing to the other. So on the other side, I've got 4x over x minus 4, and I'm going to multiply it by x minus 4. Remember that when you're using the lowest common denominator method, you need to multiply every single term on both sides of the equal sign by your lowest common denominator. So let's simplify. So over here on the left, I have an x minus 4 in the numerator and an x minus 4 in the denominator. They can cancel out, leaving me with 3x. Now for this next term, nothing canceled out, so we're just left with 3 times parentheses x minus 4. Then over here on the other side of the equal sign, we have an x minus 4 in the denominator and an x minus 4 in the numerator, and they can cancel out, leaving us with 4x. As complicated as this looks, there are no more fractions, so now that all the fractions are gone, we can solve this like we normally would. So I'm going to clear those parentheses by distributing the 3, so I get 3x minus 12. I've got a lot of terms that have a variable, so I'm going to start to put those together. So I'm going to start with the 3x plus 3x on the same side of the equal sign, gives us 6x, minus 12 equals 4x. Then I'm going to move all of the x terms onto one side of the equal sign to give us negative 12 equals negative 2x. Then I'm going to divide both sides by negative 2, giving us x equals 6, which I am not circling yet. Because, remember, for every single one of these rational equations, you do need to check your solutions. So to check our solution, we're going to plug 6 back into the original equation into every single spot that we see an x. So there's going to be a 6 right there, 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 and there. So here we go. We've got 3 times 6 over 6 minus 4 plus 3. We're going to see if that equals 4 times 6 over 6 minus 4. All right, so 3 times 6 is 18. 6 minus 4 is 2. Then on the other side, 4 times 6 is 24 over 6 minus 4 is 2. 18 divided by 2 is 9. 9 plus 3 does indeed equal 12. So because we got 12 on both sides of the equal sign when we checked our solution, that means x equals 6 is actually our solution. So this is going to be our final answer. Now for this next one, you have a couple of different options. You could use the lowest common denominator method. The common denominator is going to be x minus 1 times x plus 2. Or you could cross multiply. Because there is one fraction on the left and one fraction on the right, cross multiplying is absolutely an option. So because cross multiplying is an option, I'm going to go with that. Just keep in mind that this numerator is an x. So I'm going to cross multiply this way. I have x times x plus 2 gives us x times parentheses x plus 2. Then I'm going to set that equal to the other cross product. X minus 1 times 8 is 8 times parentheses x minus 1. Then I'm going to clear out the parentheses by distributing. So x times x, remember when you are multiplying variables together, add the powers gives you x squared. Then x times 2 is plus 2x. Equals, then I'm going to cross multiply over here. 8 times x is 8x, and then minus 8. Now, before we go any further, there is an x squared term. This is a quadratic. We learned how to solve these back in chapter 5. So you might remember that in order to solve a quadratic, you can solve it by factoring. In order to solve an equation by factoring, one of the sides of the equal sign does need to be 0, so the equation does need to equal 0. So to make this equation equal 0, I'm going to move all of the terms onto one side. And because the x squared term is positive, I am going to leave it alone, and I am not going to move it. So I'm going to move this 8x over to the other side by subtracting it from both sides. Gives us x squared minus 6x equals negative 8. Then I'm going to finish making this equation equal 0 by adding 8 to both sides, and I get x squared minus 6x plus 8 equals 0. So then from here, now that one side of the equation equals 0, we are going to solve it by factoring. So We're going to factor x squared minus 6x plus 8. So we're looking for two numbers that multiply to positive 8 and add up to minus 6, which is going to be minus 4 and minus 2, which gives us two potential solutions. When you set x minus 4 equal to 0 and solve it, you get x equals 4. Then when you solve set x minus 2 equal to 0 and solve for x, you get x equals 2. Notice how I didn't circle either of them yet, because whenever you have a solution to a rational equation, I don't care how many there are, you need to check them. So you actually need to check both of these to see if they work. You can only check one at a time, so we're going to start with 4. So to check x equals 4, we're going to plug 4 back into the original equation into all three spots that we see in x. So we have 4 over 4 minus 1 equals 8 over 4 plus 2. So then 4 minus 1 is 3 equals 4 plus 2 is 6. 4 over 3 does indeed equal 8 over 6. So 4 over 3, when you reduce 8 over 6, you get 4 over 3. So because we got the same number on both sides of the equal sign, x equals 4 is one of our solutions. So now let's check the other one. So now we're going to do the same thing with 2. We're going to plug 2 back into the original equation into every single spot that we see in x. All right, and then when we simplify, we get 2 on one side, and then 8, and then 2 plus 2 is 4. 8 divided by 4 is indeed 2. So you get 2 equals 2. So because we got the same number on both sides of the equal sign, that means 2 actually worked, and 2 was our other solution. So this particular rational equation, because it resulted in a quadratic, had two solutions, and they both worked. So x equals 4 and x equals 2 are both of your final answers. Now for this next one, cross multiplying is absolutely not an option because we have 3 fractions and you can only cross multiply when there's 2. So because cross multiplying is not an option, we're going to have to think lowest common denominators. So to start off finding lowest common denominators, I'm going to factor the denominator on the right, that x squared minus 1. So I have 3 over x plus 1, and then plus 1 over x minus 1 equals 26 over x squared minus 1 is a difference of squares. It's going to factor as x minus 1 times x plus 1. So then I'm going to find the lowest common denominator between all 3 fractions. So the lowest common denominator here, you might notice that there's some common factors, and the denominator on the right side of the equal sign is simply a multiple of the 2 on the left. So the lowest common denominator between all 3 of these is x minus 1 times x plus 1. Then what I'm going to do is I am going to multiply all 3 terms on both sides of this equal sign by the lowest common denominator, and I'm going to simplify as we go. So I'm going to take this first term and I'm going to multiply it by x minus 1 times x plus 1. Then I'm going to take the second term and I'm going to multiply it by x minus 1 times x plus 1. Then I'm going to take this term on the right and I'm going to multiply it by x minus 1 times x plus 1. And I'm going to simplify as much as I can as I go. So over here, there's an x plus 1 in the denominator and an x plus 1 in the numerator. Those can cancel out, leaving you with 3 times parentheses x minus 1. Plus, for the next term, x minus 1 in the denominator can cancel out with this x minus 1 in the numerator, leaving us with 1 times x plus 1. Then over here on the right, x minus 1s can cancel out, and the x plus 1s can cancel out, leaving you with 26. Then I'm going to, now that the fractions are gone, I'm going to simplify this and begin to solve it. So I'm going to clear out the parentheses by distributing, giving us 3x minus 3. Plus 1 times anything is, anything times 1 is itself, so x plus 1 equals 26. So I'm going to combine some like terms. So I have 3x plus 1x is going to give us 4x. Then negative 3 plus 1 is minus 2 equals 26. Then I'm going to add 2 to both sides, giving us 4x equals 28. Then I'm going to divide both sides by 4, giving us x equals 7. Before we circle it and call it good, we're going to make sure that we check our solution. So I'm going to check my answer by plugging 7 back into the original equation in for every single spot that we see in x. So we have 3 over 7 plus 1 over 7 minus 1 equals 26 over 7 squared minus 1. So 7 plus 1 is 8, so we have 3 over 8. Plus 7 minus 1 is 6 equals 26 over 7 squared is 49, minus 1 is 48. And then you can use a calculator from here. So if you do 3/8 plus 1/6, you get a 0.5416, blah, blah, blah. And then equals, if you do 26 divided by 48, you get the exact same decimal. Because we got the exact same number on both sides of the equal sign, that means x equals 7 is our final answer, and we can circle it. For this next one, it's going to be pretty much the same idea. Because there are 3 fractions, we cannot cross multiply here. So because you can't cross multiply, we're going to have to find the lowest common denominator. So we're going to look at the 3 denominators, 4, 3, and 6. The lowest common denominator between all 3 of them is 12. So I'm going to multiply every single term on both sides by 12. I'm also going to put the 3x minus 1 in parentheses. So multiply this first term by 12, multiply this second term by 12, and then I'm going to multiply this term on the right by 12. And I'm going to reduce as I go. So 4 and 12 have a common factor of 4, so 4 divided by 4 is 1, 12 divided by 4 is 3, leaving us with 3 times parentheses 3x minus 1. Plus, over here, 3 divided by 3 is 1, 12 divided by 3 is 4, 2 times 4 gives us 8. Equals, over here on the right, 6 divided by 6 is 1, 12 divided by 6 is 2, 7 times 2 is 14. So then I'm going to solve this equation like I normally would solve any other linear equation. I'm going to clear out the parentheses by distributing the 3. So I have 3 times 3x is 9x minus 3 plus 8 equals 14. Going to combine some like terms here on the left. So negative 3 plus 8 is going to give us plus 5. Then I'm going to start to solve for x by subtracting 5 from both sides, gives us 9x equals 9. Then I'm going to divide both sides by 9, giving us x equals 1 as our potential solution. So then we're going to just check our potential solution by plugging 1 back into the original equation in for every single spot that we see in x. So we have 3 times 1 minus 1 over 4 plus 2 over 3. We're going to see if that equals 7 over 6. So 3 times 1 is 3 minus 1 gives us 2 over 4 plus 2 over 3. We're going to see if that equals 7 over 6. So if you do 1/2 plus 2/3, you get 1.16 repeating. And then if you do 7 over 6, you get 1.16 repeating. So because we got the same decimal on both sides of the equal sign, that means x equals 1 is our final answer, and we finally get to circle it. Now for this next one as well, cross multiplying is not an option. We have three fractions and combining them is not going to be very simple. So because we have three fractions, we cannot cross multiply. We're going to have to use the lowest common denominator method. So I'm going to turn this whole number into a fraction by putting it over 1, and I'm just going to put parentheses around these denominators. And then the lowest common denominator between x minus 2, 1, and x minus 2 is x minus 2. So I'm going to take every single term on both sides, and I'm going to multiply them all by the lowest common denominator, x minus 2. So I have 2x over parentheses x minus 2. Going to multiply that by x minus 2. Then equals 1 times x minus 2, and then plus 4 over x minus 2 times x minus 2. Every single term on both sides gets multiplied by x minus 2. And then I'm going to simplify as much as I can. So x minus 2 in the denominator cancels out with x minus 2 in the numerator, leaving us with 2x equals 1 times x minus 2 is x minus 2, plus x minus 2 cancels out with x minus 2, giving us 4. So then I'm going to solve this like I normally would any other linear equation. So I'm going to move all of the x terms onto one side. So 2x minus x is x equals negative 2 plus 4 is 2. Now before we call it good, you need to check it. And this is where checking your answer is really going to pay off. Let's plug 2 back into the original equation in for every single spot that we see in x. So we have 2 times 2 over 2 minus 2 equals 1 plus 4 over 2 minus 2. 2 times 2 is 4, 2 minus 2 is 0, equals 1 plus 4 over 0, and we're going to stop right here. 4 over 0 is undefined. You cannot divide by 0. So because you cannot divide by 0, and when we plugged in our solution, it looks like we did everything perfectly, we got something that was undefined. We got a non-real answer. Because of this, 2 doesn't actually work, because when you plug 2 back into the original equation, you get something that's not real. You get something that's undefined. You don't get an actual number. So that means 2 does not satisfy the equation. So this solution that it looks like it should be our answer actually isn't. This is what is called an extraneous solution. It looks like it should work. It looks like it should be our answer, but when we plugged it in, it didn't actually work. And because this was our only potential solution, and it was extraneous and it didn't work, this equation actually has no solution. So please be very careful of this. You do need to check your answers every single time, even if you check them mentally. Even if you could take one look at this and know, oh yeah, x equals, if I plug in 2, I'm going to get 0 on the bottom. Just check your answers every single time, because extraneous solutions are a reality. So just make sure that every single time you check your answers, and remember, you cannot have a 0 in the denominator. So for this next one, it's going to be pretty much the same idea. I have 3 fractions, so I cannot cross multiply. So I'm going to have to use the lowest common denominator method. The lowest common denominator here is going to be x minus 4. So I'm going to multiply every single term on both sides by the lowest common denominator, x minus 4. So I have 3x over parentheses x minus 4. Going to multiply it by parentheses x minus 4. Then on the other side, I'm going to take this next term 5 and I'm going to multiply it by x minus 4. Then I'm going to take this last term 12 over x minus 4 and I'm going to multiply it by x minus 4. And then I'm going to simplify as I go. So x minus 4's over here cancel out, leaving us with 3x equals 5 times parentheses x minus 4 is fully simplified. Then over here, the x minus 4's can cancel out, leaving us with 12. And then I'm going to distribute the 5 and begin to solve for x. So I have 3x equals 5x minus 20 plus 12. Then I'm going to combine like terms and move all of the x terms onto one side. So I'm going to subtract 5x from both sides, giving us negative 2x equals negative 20 plus 12 is negative 8. Then I'm going to divide both sides by negative 2, giving us x equals 4 for our potential solution. Remember, this is not actually a solution yet until we check it. So to check our answer, we are going to plug 4 back into the original equation into every single spot that we see in x, and we're actually not going to get very far. So I don't even need to do the rest of it, because if you take a look at this denominator is going to give you 12 over 0. Remember, you cannot divide by 0, so you cannot have 0 in the denominator. This is undefined. Because 12 over 0 is undefined, that means x equals 4 doesn't actually work. So this is an extraneous solution. We've got another one. Because our only potential solution was extraneous because it gave us something undefined, for our final answer, this equation has no solution. So just be very careful of the potential for extraneous solutions. So we're going to do basically the same thing for this next one. Because there are 3 fractions, cross-multiplying is not an option, so we're going to have to use the lowest common denominator method. So the lowest common denominator here is going to be x plus 2. So I'm going to multiply every single term on both sides by the lowest common denominator, x plus 2. So I have 5x over x plus 2. I'm going to multiply it by x plus 2. Then over here, I'm going to take 3. I'm going to multiply it by x plus 2. Then I'm going to take this last term, minus 10 over x plus 2, and I'm going to multiply it by x plus 2. All right, we're having all kinds of technical problems. So anyway, when you plug -2 back in, I don't think it recorded any of that audio, I'm sorry. So when we plug -2 back into the original equation, you get -10 over 0. Now, -10 over 0 is undefined. This is not a real answer. So because -10 over 0 is undefined, that means that x equals -2 doesn't actually work. So because -2 doesn't work, and it looks like it should have, this was an extraneous solution, because when we plugged it back in, we got something that was undefined. And because this was our only potential solution, that means that this equation overall has no solution. So, sorry about that. I don't know what is going on with my technology today, but we will do the best that we can. So looking at this next one, now because you have one fraction here on the left and one fraction here on the right, you can cross multiply. Because you only have two fractions and there's one on the left and one on the right. The only thing I am going to do though is I am going to put parentheses around that x plus 4, and I'm going to cross multiply and begin to solve for x. So let's cross multiply. We have x times x, which is x squared. And I'm going to set that equal to 2 times x plus 4 is 2 times parentheses x plus 4. Now, if you take a look at this, there is an x squared term here. Because there is an x squared term, that means that this is a quadratic, and we're going to be solving this by factoring. The first thing I'm going to do is I'm going to distribute that 2 to give us 2x plus 8. And then remember, in order to solve a quadratic, one side of the equation needs to equal 0. So I'm going to move each of these terms over to the other side by subtracting each of them. So on the left, I'm going to get x squared minus 2x minus 8 equals 0. Now that the equation equals 0, now I am going to factor this, so I'm looking for two numbers that multiply to -8 and add up to -2, which are -4 and plus 2. So when you set each of these factors equal to 0, so we get x minus 4 equals 0. When you add 4 to both sides, you get x equals 4 as one potential solution. Then we're going to set the other factor, x plus 2 equals 0, subtract 2 from both sides, and we get x equals -2 as our other potential solution. So, as we've seen a couple of times already, extraneous solutions can happen, so you do need to make sure that you plug both of these solutions, one at a time, back into the original equation in for x. And you have to check both of them, and you can only check them one at a time. Because as we saw, extraneous solutions can sneak up on you, so make sure that you check your answer every single time. Let's start with 4. So checking x equals 4, I'm going to plug 4 back in for x into all three spots that we see in x. So we have 4 over 4 plus 4 equals 2 over 4. So 4 plus 4 is 8. 4 over 8 does indeed equal 2 over 4 because these both come out to 1/2. So because we got the same number on both sides of the equal sign, that means x equals 4 is one of our solutions. Next, I'm going to check x equals -2 by doing the exact same thing. I'm going to plug -2 back into the original equation in for every single spot that we see in x. So I have -2 over -2 plus 4. We're going to see if that equals 2 over -2. So -2 plus 4 is going to give us 2. And as you can see, we do get the same number as on both sides of the equal sign. So we get x equals -1. I'm literally plugged right into the router. I don't know why it's whining that the internet's slow. So because we got the same number on both sides of the equal sign, that means x equals -2 was another solution. So both of these were our solutions because they both worked. So this next one is going to be pretty much the same idea. Because we have one single fraction on the left and one single fraction on the right, we can cross multiply. So when we cross multiply, just remember that I am going to put parentheses around the x plus 6 because it does need to stay together. So because we have two fractions, let's cross multiply. So x times x gives us x squared equals x plus 6 times 3 is 3 times parentheses x plus 6. Now, because we have an x squared term here, that means this is a quadratic, and we are going to solve quadratics by factoring. So we're going to get x squared equals, let's distribute the 3, we get 3x plus 18. Remember, in order to solve a quadratic, the one side of the equation needs to equal 0, so I'm going to move each of these terms over to the other side by subtracting them. So I get x squared minus 3x minus 18 equals 0. Now that the equation equals 0, we are going to factor this, and we are going to solve it. So, because that is a 1x squared, there's going to be an x here and an x here. And we're looking for two numbers that multiply to negative 18 and add up to negative 3, minus 6 plus 3. So then you're going to set each factor equal to 0 and solve for x. So looking at x minus 6 equals 0, when we add 6 to both sides, we get x equals 6. Then for the other solution, we're going to take x plus 3, set it equal to 0, and we're going to subtract 3 from both sides, giving us x equals negative 3. Now, at this point, remember, you must check your answer by plugging each of these one at a time back into the original equation in for every single spot that you see in x. Let's start with 6. So we have to check x equals negative 6. Sorry, x equals 6. I'm going to plug 6 in for that x, so we have 6 over 6 plus 6. We're going to see if that equals 3 over 6. So 6 plus 6 is 12. 6 over 12 is 1/2, equals 3 over 6 is 1/2. So because we got the same number on both sides of the equal sign, that means 6 is one of our solutions. Now we're going to check x equals negative 3 by doing the same thing. I'm going to plug negative 3 back into the original equation in for every single spot that I see in x. So I have negative 3 over negative 3 plus 6, and we're going to see if that equals 3 over negative 3. So negative 3 plus 6 is going to give us 3. And then, as you can see, we do get the same number on each side of the equal sign. We get negative 1 equals negative 1. So because we got the same number on both sides of the equal sign, that means x equals negative 3 actually worked, and x equals negative 3 is one of our solutions. So this equation, just like the last one, gave us two solutions. So there are three possibilities with rational equations. You could get one solution, you could get two solutions, or you could get no solutions. And which one you end up with depends entirely on what the equation looks like and how the equation is set up. So now that the subtitles are glitching again, I think this is a great time to stop. So thank you all very much for watching. This is actually the last section of Chapter 6. So this is Section 6.5. So when we come back to this lecture series, we're going to be moving on to the next chapter, which is Chapter 7. Remember, your next exam, your third exam, is going to cover all of Chapter 6, and it is going to cover everything from the beginning of Chapter 6 all the way through the end of Chapter 6. So if you had any questions about either this video or any of the others, please feel free to email me, and I will see you all in the next video for the next chapter.